Hello everyone, today let's solve the problem number 338 counting bits, right? So let's see what the question states here. We are given an integer n, so we have to return an array answer of length n plus 1, right? So we have to return an array of array answer of length n plus 1 such that for each I, so see here, I greater than or equal to 0, less than or equal to n, right? So and answer of I is the number of ones in the binary representation of I, right? Simple one, very simple one, right? So so we have been asked to do this one in the linear time, nothing but the big of n, without using any built-in functions, right? So they have asked here, follow you can just go through that one, right? So we'll be we can make use of the bit manipulation to solve this particular problem, right? So again we can just make use of the bit manipulation to solve this particular problem, right? So I'll just write here bit manipulation, bit typing, right? So this is fine. We'll be making use of the bit manipulation to solve this particular problem. So let's move on with the first this one example. So let's directly, I'll just explain this approach. You can just try to implement the same thing or articulate the same thing for the example 2, right? So first thing here, we have n equals 5 here, n equals 5, and we have to compute this one. Let's consider this one itself, right? So this one is bigger one than this one, right? So if we consider for this one, you'll understand the example 1 as well within that itself, right? So I'll just consider n equals 5 itself rather than n equals 2. This is fine one. So we have to compute 0 1 1 2 1 2, right? So output that we need to get here is this one, right? So first step, this one, the first step here would be, so we have to go with the 0 first for the 5, right? So in the question what they have asked, we have been given integer n, we have to return the array answer of length n plus 1, of length n plus 1, where answer of I is the number of ones in the binary representation of I, binary representation of I, right? So this one, first let's consider 0, so this one we have to go until 5, right? So see here, 0 1 2, as it starts from 0 we have to go till 4 actually, 0 1 2 3 4 5 itself, right? So n plus 1 we have to go with, n plus 1 in the question they have asked, we have to this one, what do we call, we have to return an array answer of length n plus 1 they have given, right? So this one has to go until this one, what do we call, 5 basically, 0 1 2 3 4 5. So this is fine. For this we'll be considering only 0 1 2, and this is fine. Yeah, let's consider for this one, man. First we have 0 for the 0, right? So binary is 0 and we have 0 ones here, so answer of 0 will be 0 as well, right? Next step we will be considering 1. For 1, so we have to go for 0 1 2 3 4 5 for the n equals 5, right? So for 1, binary representation is 1 itself, we have 1 1, right? So we have 1 1 here, so answer of 1 will be 1. So for the step 2 we'll be considering 2, we are going with 2, this one, right? So binary representation would lead to 1 0, so we have 1 1 here, right? So we have 1 1, so we will be going with this one, what do we call, answer of 2 equals answer of 2, and we will be going with a bit manipulation, as I've said, we'll be going with a logical AND here, right? Bitwise AND, sorry, yeah, this one, answer of 2 bitwise AND 2 minus 1 whole plus 1 basically. So this will be answer of 0 plus 1, right? Answer of 0 plus 1 would lead to answer of 0, we have this one 0, so 0 plus 1 would lead to 1 itself finally at the end, right? This one you'll understand this one crystal clear when I write the code. So we will be going with answer of the current number, nothing but 2, this one, answer of the current number 2, logical and or the bitwise, and this one the current number minus 1 plus 1 whole plus 1, right? So this with this formula we'll be going with basically, right? So next we have to go with the 3. For the 3, the binary representation is 1 1, we have 2 ones here, right? Answer of 3 is answer of 3, the current number, answer of this one within the array 3, and logical and this one bitwise and 3 minus 1 basically, right? Plus whole 1, this one, this will be equivalent to the answer of 2 plus 1. Answer of 2 what we got here, answer of 2 we have got 1 here, so this one will be answer of 2 plus 1, this one answer of 2 is 1, so 1 plus 1 will lead to 2 basically, right? For 4, let's consider 4. So binary representation they have given here 1 0 0, right? So let's consider the binary representation 1 0 0, right? So let's consider 1 0 0 here. We have only 1 1 here, right? So again, now answer of 4 equals answer of 4 bitwise and 4 minus 1 plus whole 1, this one, right? Whole plus 1. So this will be answer of 0 plus 1, because we have only 1 1 here, right? So we'll be going with the answer of 0 plus 1. Answer of 0, we have 0 here, right? So this will be 0 plus 1, which lead to 1 here, right? So this is fine. Finally what we will do, finally we have to go with the 5. Basically 5, the binary representation for this one would be 1 0 1. So we have two ones here again. So answer of 5 will answer of 5 and 5 minus 1 plus whole 1, this one. This is fine. This would lead to answer of 4 plus 1. Answer of 4 we have here 1. Answer of 4 plus 1 we have we should be going with 1 plus this one. Answer of 4 is 1 plus 1 would lead to 2 basically, right? So 2, this one. 0 1 0 1 1 2 1 2. 0 1 1 2 1 2 is the answer that we got here. 0 1 1 2 1 2, right? So the output that we got here is 0 1 1 2 1, and finally we got 2 here, right? So this one, the output that we got here is 0 1 1 2 1 2, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n. So why it is big of n here? Because each number is processed exactly once. So the time complexity would lead to big of n. So what will be the space complexity here? The space complexity would lead to big of n as well, right? So why the space complexity is big of n? So the space complexity would lead to big of n because we will be making use of the array of size n plus 1, right? So overall space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. This is fine. So now as we are completely familiar with the approach and the complexities part, we are good to write code. Let's start writing the code. So now let's do one thing. Let's do one thing. Let's start writing the code as I've said. So first let's create the array to store the number of ones for each number. We have discussed this one, size n plus 1 just now, right? So this one will be answer equals new int size n plus 1. The next step would be we have 0 has 0 ones in the binary, right? So first let's initialize this one, base case. So this one, let me initialize this one to 0. So let's move on with the iteration part. So this one will be int I equals 0. We have to start with a 1, right? We have already considered for 0. So I equals 1, I less than or equal to n. So this will be I plus plus. So what is the formula that we went with? So every step that I showed, right? Answer of I. So I said this one, when we considered 3, this one, answer of 3 bitwise and 3 minus 1 whole plus 1, right? So that itself is the basically formula that we'll be going with. So this one I can represent in this way, answer of I bitwise and again, so you have to know the bitwise and truth table we all know, man. So this one a b, so we have here 1 0 1 1 0 0 0 1 and 1 0. So yeah, 1 0. So only when a and b are 1, then only it is 1, else it is 0 for this one, logical AND or the bitwise AND. Here just this is the result basically. This is fine. So this one you have to know at any cost, right? So this is fine. So we'll be going with the answer of I, and so this one will be I minus 1 whole plus 1. This is fine. So the final step would be we have to return the final array. In this case we have to return just answer. Yep. Let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.